Hi, this is Alex from devstories.eu. Pydantic, Data Validation, Episode 18 of 20. By default, Pydantic silently ignores any extra JSON keys you send it. In a strict API, swallowing unknown data without warning is a massive security risk. To fix this, you need fine-tuning model configuration. To change how a model behaves globally, you define a class attribute named model_config. You assign it a typed dictionary imported directly from Pydantic. You place this assignment right inside your model alongside your field definitions. Because typed dictionary is typed, your code editor will catch typos if you try to pass an invalid configuration option. Whatever rules you put in this dictionary will dictate how the entire model parses, validates, and stores data. Let us build a strict security settings model for an application. A malicious client might send a JSON payload with unexpected fields, perhaps trying to inject an admin flag or overwrite a hidden parameter. By default, Pydantic sets the extra fields behavior to ignore. It reads the fields it expects, silently drops the unknown data entirely, and creates the model. To close this loophole, you add the extra parameter to your ConfigDict and set its value to the string forbid. Now, if a client sends an unexpected key, Pydantic immediately throws a validation error. The request fails outright, explicitly rejecting the bad payload before your application logic even processes it. That handles the boundary between the outside world and your system. But what happens inside your system after the model is created? Pydantic normally only validates data during initialization. If another developer writes code that changes an attribute on an existing model instance later on, Pydantic stays out of the way. You could accidentally assign a raw string to an integer field and the model would accept it. To prevent this, you can set validate assignment to true inside your ConfigDict. With this enabled, anytime an attribute is modified in memory, Pydantic intercepts the change and runs the exact same validation logic it uses during creation. Sometimes, even validating mutations is too permissive for security configurations. You might want an absolute guarantee that the settings cannot be modified in memory by any part of your code once they pass the initial check. This is where it gets interesting. You can set the frozen parameter to true in your model configuration. This makes the entire model instance immutable. If any downstream function attempts to update a field, Pydantic raises an error. A frozen model acts exactly like a Python tuple. Because it cannot change, a frozen model is completely safe to share across different parts of your application, and it can even be safely used as a key in a Python dictionary or an in-memory cache. By stocking these configuration options inside your ConfigDict, you shift a model from a flexible data parser into an absolute unyielding boundary. That's all for this one. Thanks for listening and keep building.